Good day to you, Panther students. Welcome back to another video tutorial. We are going to expand on the last video where we took a look at complementary and supplementary angles by adding a different angle relationship type to our toolkit, so to speak. And we are going to begin by doing a couple of warm-up problems that deal with the content covered in the last video. So if you have not watched the video on complementary and supplementary angles, I strongly advise you to do so before moving on with this video. Okay, so use your knowledge of complementary and supplementary angles to solve for angle Y and angle X. So we're going to start with angle Y right here, and I can tell that these two angles are complementary because when we add them together, they are going to give us a right angle. Okay, which means that when we add both of them together, okay, Y plus 23, that should give us a total of 90 degrees. Okay, and just like, in the last few examples we did in the last video, we are going to end up with a one-step equation. So we're going to try and isolate Y, and we're going to do that by canceling out this plus 23 here in the center. So we want that to equal 0, and the way that we make positive 23 equal 0 is by subtracting 23 from it. Okay, so that makes that cancel out, but as always, the rule of equations, is whatever you do to one side, you have to do the exact same thing to the other. So if we're going to subtract 23 from the left-hand side, we have to subtract 23 from the right-hand side. Okay, and that's going to leave us with Y equals 90 minus 23, which is 67. So this angle right here is equal to exactly 67 degrees. Okay, let's go ahead and move on to the second problem where we are instead dealing with angles that are supplementary. Okay, when I add all three of these angles right here, okay, the 55, the 108, and angle X, we are going to get a total of exactly 180 degrees. Now I'm going to give myself a little bit of a place to work here. These backgrounds may look nice, but they can sometimes get in the way and make it hard for people to follow your work. Okay, so let's write down exactly what we talked about. So I know when I add angle 55 and 108 and angle X, we know that is going to give us a total of exactly 180 degrees because they all equal the length of a straight angle, and a straight angle is always equal to 180 degrees. Okay, so let's go ahead and combine our like terms. So I see we have two values right here without a variable. So when we add those together, that's going to give us 100 and, oops, I almost did it wrong. So 163. Let's go ahead and double check that just to make sure. 55 plus 108 equals 163. Excellent. So we combined our like terms, and everything else we just bring straight down. So plus X equals 180. And just like now with the complementary angles, we are now dealing with a one-step equation. So we want to cancel out this positive 163 degrees, and we're going to do the same thing we did, except this time we're going to subtract 163 from both sides. That is going to cancel out the 163 on the left, and that means that we're just going to be left with x equals 180 minus 63, which is equal to 17 degrees. And once again, let's use our handy dandy calculator just to double check. 180 minus 163 equals 17. Very good. Okay, so angle X right here is equal to exactly 17 degrees. And there we go. We are done. So let's go ahead and move forward. Today we are going to talk about a couple of different things. Our main focus is going to be on vertical angles. Okay, on vertical angles. Okay, and then we're also going to give a bit of attention to a topic that or a particular kind of angle, or of linear intersection called perpendicular. Okay, lines that are perpendicular. And my goal by the end of this video is to have you confident and able to identify vertical angles. Okay, you should be able to look at two lines that are intersecting and identify which pairs of angles are vertical to each other. Okay, and then I also would like for you to be able to explain when the angles created by these two lines that intersect, when are they going to be right angles, okay, or angles that are equal to exactly 90 degrees, and that has to do with lines that are perpendicular. Okay, so we will get to all of this in just a moment, okay, but those are the goals for today's video. Okay, so let's kind of, continue to warm up a little bit by reviewing what we talked about last week. So we talked about how, okay, you have one line. Okay, now there are two angles. Okay, one on either side of this line. Okay, we have one angle right here. Okay, that is a straight angle, and that is going to be equal to exactly 180 degrees. Okay, and we also have another angle on the other side of this line here. Okay, and this is also a straight angle, meaning that it is equal to 180 degrees. Okay, and when we put both of them together, okay, they equal 360 degrees, right? 180 plus 180. That is the total number of degrees in an entire circle. Okay, which is how mathematicians in the past came to the decision that straight angles would be equal to 180 degrees, because a straight angle is half a circle. Okay, so now what would happen if, okay, we took this exact same line, okay, and these same two angles, okay, and then we had a second line intersect the first line. Okay, so now we have taken, okay, that first line and those two angles, and we're going to have a second line go right through the middle of the whole thing. Okay, so what I would like for you to do is, okay, and I know that, describing these kinds of things in math is a bit difficult. So a lot of times, you think to yourself, I can see it, but I can't put it into words. Okay, I want you to try to, even if you're just kind of writing it down. Okay, I want you to take a look and see what happens when we add a second line that cuts through the middle of this. Okay, there's one very important thing, and I'll give you a hint. It has to do with the two angles. Okay, something happens to those two angles when we draw a second line that goes through them. Well, hopefully you have noticed that we started with one line and two angles, Okay, and when we add that second line, we now have 4 angles. Okay, we have cut these angles into 2. Okay, let me get my writing tools out. Okay, and as you can see, we have 1 angle right here in blue. We have a second angle right here in red. We have another angle here in blue, and then another angle here in red. Okay, now this is where the idea of vertical angles comes from. Okay, this is an example of vertical angles. Okay, or there's sometimes referred to, okay, most of the time, especially when I was in school, they were referred to as vertical angles, but it has become popular to refer to them as opposite angles. Okay, but it's 2 different ways of referring to the exact same thing. Okay, so vertical angles and opposite angles, same thing. Okay, now with vertical or opposite angles, okay, down here in orange, okay, this is a word that I want you to get used to, okay, if you're not already. Okay, and this word here is congruent. Okay, and congruent is a fancy way in math of saying that two things are equal. Okay? Or you can think of it as saying that 2 or more things are the same. Okay? Okay, and we're going to kind of break one of the rules of geometry, which is you never really want to eyeball these things. Like, you know, in high school, you won't want to take a look at, you know, certain problems and judge them based on sight alone. Okay, the information that's given to you is basically all you have to get through the problem. But for this, we're going to kind of break that rule. If you look at both of these angles here in blue, okay, you can tell by looking at them that, okay, they look like they are about the same distance, okay, and in fact, they are the exact same distance. Okay, same with these 2 angles here in red. Okay, if you just look at them closely, okay, you might say to yourself, they look like the exact same angle. And they are. So if I were to tell you that this red angle right here, if I were to tell you that that is 45 degrees, okay, what does that tell us about this red angle right here? Okay, it's vertical or opposite angle. Okay, well, we just discussed how vertical and opposite angles are congruent, so that means if this angle is equal to 45 degrees, then this angle right here is also equal to exactly 45 degrees. Okay? And up here, if I were to tell you that this blue angle up here was equal to 100, and I don't really want to use the same colors, you know, that I've used before. About a brown color. Okay, so if I were to tell you that this blue angle up here is 135 degrees, okay, that should tell you everything you need to know about its vertical or opposite angle. Okay, that means that this is also equal to 135 degrees because both of these angles are congruent, okay, or exactly the same, okay, or equal, whichever way you prefer to think of it. Okay, congruent is one of those words that I'm going to want you to store in your memory for the foreseeable future, because we're going to be using it a lot. Okay, so on the screen here, I have a a couple of different lines, okay, kind of going every which way. And so we're going to select the two arrows below and have them, or select two arrows below and have them intersect each other. Okay, so let's just kind of pick, let's pick two at random. So let's pick yellow, and we'll pick orange. Okay, and we'll just kind of, we can have them intersect basically anywhere, but to get the best view of things, kind of have them intersect there in the middle. Okay, and once again, just like before, okay, we start out with two straight angles. Okay, and when we have that second line go through it, okay, instead of having two angles, we now have one angle here. We have one angle here. We have a third angle here. And we have a fourth angle right here. Okay, and as you can see, we have two pairs of vertical or opposite angles. Okay, so, and I know the drawings don't really look like it, but you can tell by looking at the two arrows themselves. Okay, you can tell, okay, if I tell you that this angle right here is equal to, we've used something in the 40s, let's say 59 degrees, that gives you the exact measurement of its vertical or opposite angle right here. Okay. So hopefully that's starting to set in, and if you're asking yourself, wait a second, does that mean that these two, let's use a darker color. If you're asking yourself, does that mean that these two angles right here are exactly the same? The answer is yes. Okay, so if I tell you that this angle here is equal to 121 degrees, that means that this is also 121 degrees. Okay, and this relationship between these four angles, okay, where you have two pairs of vertical angles, it'll happen no matter which two lines we select. Okay, so let's kind of put those back. There they go. Let's pick two different ones. Okay, how about this one right here? And let's just I'll just pick one at random. Okay. Go back to this one. Okay, and again, you can, they don't have to intersect necessarily in the middle. Okay, you can intersect them up top, but in the middle is typically the best if you want to get a good view of the angle relationships. Okay, and if you look at the four angles, okay, we have one angle here, one right here, we have a third one right here, and a fourth one right here. You can see that these two angles here, let's kind of color that in. Again, I'm using a mouse, so it's not going to be the best coloring job. Okay, you can see that these two angles right here, okay, doing the eyeball test, okay, we're kind of breaking the rules of geometry here a little bit. You can tell that those are basically the exact same measurement, okay, and they are. Okay, same thing with this angle right here. And color that in. And this angle right here. Okay, two of the exact same thing. Okay, the two angles in red are congruent, and the two angles in green are also congruent. Okay, and once again, we can use any of these lines that we want in order to make that happen. Let's use one more. How about those two? Okay, that's kind of interesting. Okay, so let's see. Maybe it'd be better to use the highlighter. No, that is definitely not better. Okay, so let's start and take a look. Okay, we have angle 1, we have angle 2, we have angle 3, and we have angle 4. Okay, now what I would like for you to do is, I would like for you to pair these numbers together based on whether or not they share a vertical relationship. Okay, so for example, so angle 1. Which of the 3 other angles are vertical, or is vertical to angle 1? Well, it's angle 3. Okay, angle 1 and angle 3 are vertical angles. Okay, so that angle there and this angle right here are vertical, meaning they are congruent. Okay, and then if I were to ask you, okay, so let's take angle 4. Which of these other angles is vertical or opposite to angle 4? Well, the answer should be pretty obvious by now. Okay, that would be angle 2. Okay, these two are congruent and these two are congruent, and we know that because vertical or opposite angles are always congruent. Okay, always. All right. So again, if you imagine, okay, we could pick any 2 of these 8 and it'll work. Okay, but what would happen if we selected the horizontal line, okay, which is this orange one right here, and the vertical line, okay, which is this pink line right here? And I'm going to do this. I'm going to group them together real quick. When you take a line that is perfectly vertical and perfectly horizontal, you end up with that special kind of line intersection that we discussed on the title screen. Okay, you end up with lines that are perpendicular. Okay, and what that means is, that means that all of the angles created between the 2 lines are equal to 90 degrees. Okay, so that means that this angle right here, well, that's 90 degrees. Okay, 90 degrees. That means that this angle right here is also 90 degrees. Okay, and following the rules of vertical angles, if this angle right here in red is equal to 90 degrees, that means that its vertical angle or opposite angle is also equal to 90 degrees. Okay, and if this angle in brown right here is equal to 90 degrees, that means that its vertical angle, if they are congruent, which all vertical angles are, must also be equal to 90 degrees. Okay? And if you want a little bit more of a proof here that that all of this does in fact check out, what shape have we created here between all 4 of our angles created by the perpendicular lines? Well, we've created a square. Okay, and what do we know about a square? We know that all 4 interior angles are right angles, meaning they are equal to 90 degrees. Okay, so the big takeaway from this, okay, regarding perpendicular lines is it's a special type of intersection between 2 lines where, you know, yes, we have 4 angles just like we would if we took any 2 of these other lines, okay, and crossed them over together. Okay, but what makes this intersection special is the fact that we create 4 congruent angles around them. Okay, and that happens even if we rotate. Okay, so the lines, you know, can kind of be diagonal. Okay, if they come in at 45 degrees, or, you know, It just depends. But we're going to start with the most common type of perpendicular lines, and that's, you know, the horizontal line and the vertical line coming together. Okay? All right. So, let's go ahead and do a quick example problem. Okay, so we'll call this example number 1. Okay, so I'm going to tell you that this angle right here is equal to 100 degrees, and I want you to tell me what angle Z right here is equal to. Well, hopefully, okay, you've arrived at the conclusion that if this angle here is equal to 100 degrees, that means that the angle that is opposite or vertical to it is also equal to 100 degrees. So angle Z is also equal to 100 degrees. Okay. Let's go back. Okay, and we'll do example 2. If I tell you that this angle here is equal to 16 degrees, what does that tell you about angle... That was supposed to be an M. What does that tell you about angle M? Well, it means that it is also equal to exactly 16 degrees. Okay? All right. So, we're going to leave it there for now. Okay, and I want to let you guys know that on Thursday, okay, when Thursday's video comes out, we're going to kick up the difficulty just a little bit because, okay, we're going to have angles that are vertical, okay, but I'm going to give you, instead of an exact measurement in degrees, I might tell you, okay, that angle 1 is equal to 3y plus 15, and this angle right here will be equal to 6y plus 30. Okay, and I will ask you to figure out what y is equal to, and that will give you the exact number of degrees on both sides. Okay? All right. So there are a couple of new con assignments. Okay, one is simply, looking at two angles that are given to you, and you're going to tell me, okay, are those two angles vertical? Are they complementary? Or are they supplementary? Okay, that's the first assignment. And the second assignment is going to be exactly what we did here with examples 1 and 2. Okay, I'm going to give you, there'll be one angle that's given to you, and you'll have to tell Con, okay, what's this angle here? If this is 16 degrees, well, that means that this is 16 degrees. Okay, if this angle here, if this angle here is 122 degrees, okay, then what's the measure of that angle there? Okay, it's as simple as that. And we'll kick up the difficulty in the next video. Alright, you guys, thank you very much for your time. As always, let me know if you have any questions, and I will talk to you guys soon. Take care.